It's a very well-known problem. How do you design a URL shortening service, right? It's very common, asked in many interviews, and right. And what we're trying to see is that all these models that we learned, how do we talk about them during an interview, and what are the things that we need to think about? So it's great to know it's great to know just these concepts. It's important for you to think out loud and talk about them and connect them to solve a problem. So the problem that we are going to pick is designing a URL shortening service. Anyone knows what a URL shortening service is or has used? I'm sure people have used. Do you want to describe what this is? Yep, that's right. goo.gl or bit.ly shortens long URLs as the name suggests. No rocket science. Yep, thanks Piyush. So ak.ms as well. Yes, that's right. So ak.ms is Microsoft. We use it internally a lot. That's great. You know about it. Cool. So like Piyush mentioned on the chat, like URL shortening is just to create shorter aliases, right? It's a very interesting service. For example, if I give this webinar's link on, let's say, tiny URL, it will give me the short link and then I can share it on Twitter or somewhere, right? It's pretty interesting. And but if you had to design this system, what are the things that you need to think about, right? So with any system design problem comes a lot of structure on how you want to solve it. What are the things that you want to tackle first, right? And the first thing generally that comes up is like, what are the functional requirements, right? You want to make sure you have clarity with your interviewer. Hey, what are the requirements that you're looking for, right? And so functional requirements, there are non-functional requirements, and then, there are extended requirements. Good to have. So what are these requirements in case of this, right? So given a URL, our service should generate a shorter and unique alias of it. This is called a short link. This link should be short enough and easily copied and pasted in the application, right? When users access the short link, we should redirect them to their actual original link, right? That makes sense. A user should optionally be able to pick a custom short link URL. So I could say, hey, I want it to be some, ABCD or whatever, and that could be like the short link. And then links, basically after some time of some standard default time span, you can say that, these links expire, and, maybe have that configuration. Customers can say, I want it for so and so duration. So those become your functional requirements. You want to make sure what the interviewer is looking for. What I want to call out specifically is that generally when you're going through the system design problem, almost always your interviewers kind of have already a solution in mind. They are going to nudge you and give you hints, but it's basically on you to make sure that you cover everything and you get the most out of them. So you would want to align with that, and of course feel free to talk about everything that you know and what makes sense here. So those are the functional requirements. The non-functional requirements would be like the system should be highly available. This is required because if our service goes down, basically your direction would work. So all those folks who use our service to sort of give the short URLs, that won't work. So that becomes a non-functional requirement. Or it should happen with real time with minimum latency. And the extended requirements would be, it would be great to have some analytics, right? All softwares will eventually require some kind of analytics so that you can determine how to make improvements, where to make improvements, and all that, right? And maybe it would be great if our service is accessible via REST APIs. So those are the requirements that we have while we try to solve this problem, right? Once you have the requirements from your interviewer, what you're going to think about next is, okay, anyone wants to take a call at what could be like the next thing we think about, right? So we have an interviewer. He has a functional requirement. You have got that clarified. How do you go next? What do you do next? Sure, Ritesh, go ahead. Ask question. Architecture, right? Sure, all these are right. But one thing that, at least the way I'm thinking about is that I want to have is, what are the next? Like I have the functional requirements, but what is the usage going to be like, right? I mean, if there is really not going to be that much usage, or it's probably an internal service only meant to be used by this internal folks, the way you design the system will be very different from, let's say, if this is a public service, and right, its requirements are several times more. So the next thing that generally comes is capacity estimation and constraints. you would want to understand what is the capacity going to be like, and so that when you talk about your systems, you can talk about that. Fit it on a node, whether it will make sense to fit it across nodes, right? Those things are determined by these numbers. It's a little bit of maths, but it's trivial maths. It's not that hard. So I'll go through this. Right. So our systems will be read heavy because we are a URL shortening service. Someone's gonna come and register their URL once, and then there are like n number of people that are gonna use it, right? That's how you will like talk about it. And then you say, probably it's a good idea to make it 100:1 ratio. One thing that I want to make again call out is these assumptions that we make. They need to be somewhat reasonable. They'll come with more practice, but there's actually a next step. Even these assumptions can have their own research, right? You can go into do some research. This is the use case, or you have done some study. But let's park that for now, and let's just say you have these ideas about what these numbers are going to be like. You come up with them something that makes sense, and then you design your system with that. And I think that's okay because what they are looking for is how you design your system. It's great if you can think about how these numbers come up, why these numbers come up, but that's like part 2, right? I mean, that's good to have. So, right. So what we're going to assume is that there's a 100:1 ratio between read and write. And so, I mean, again, some random number out there, we say like there are 500 million new URL shortenings per month, right? So what is the basically expected, redirections we get seen? So if there are 500 million in a month that people register, and we have a ratio of 100:1, that means 500 million into 100, that makes it 50 billion, right? So the number of redirections that we are looking for is 50 billion in a month. The number of registrations we are looking for is 500 million. Right? Then once you know that, like, what will be the queries per second for our system, right? So it's 500 million. So you divide that by, let's say, 30 days, 24 hours, and 3,600 seconds, then you get 200 URLs. And it's interesting to talk about it. I mean, it's interesting to think about it, that you're thinking through all these scenarios, that there are going to be these many queries per second. It's good to know, and because your systems are going to have some constraint and they should fit in the problem you're trying to solve, right? Yeah, and then considering the same 100:1 read-write ratio, the number of redirections are going to be like 200 into 100. Right? So everyone with me till now, I'm going to talk more about constraints, but I want to make sure everyone is following.
Yes.
Right. So again, now that I'm talking about estimates, the another interesting aspect to think about is, how many kind of estimates are there. So this is what we did is a traffic estimate. Right. The next one could be storage estimate. Right. Fine. We know this is going to be the traffic. This is how the traffic is going to look like. But how much storage are we going to consume? Right. That could be like the next question. So again, you can go through this. Let's assume we store every URL shortening service, right, for 5 years, and considering we're going to have 500 million URLs every month, so the number of objects, right, that we're going to have is like 500 million into 5 into 12, right? Because we have 500 million per month into 12 and then into 5. So that many, the 30 billion records is something that we're going to have. Right? And then the next question would be that, hey, what is this each record size going to be like? And let's just take another number, let's say 500 bytes, right? So if you take 500 bytes, it becomes 15 TB. So now you have a storage estimate. Of course, this number that you come up with should also be well defined when you design your objects, right? So you will know the exact numbers. But for now, you can just take a ballpark number and say, you know what, we need like 15 TB of local storage, right? So 15 TB of storage. So now you know what the storage. So you know about the traffic estimates. You know about the storage estimates. So the next estimate is on bandwidth, right? And so what is the bandwidth requirements going to be like? Like what would be the network requirements you would need? So since we have 200 new URLs every second, right? So total incoming data for our service will, let's say, be 100 KB per second. Yeah, so 200 into 500 bytes makes it 100 KB per second, right? And for read requests, again, they're going to be 20K requests. We saw that in the previous estimations that we made. And since each of those requests is going to be 500 bytes, it's going to be 10 Mbps, 10 MB per second, right? And then there are more estimates coming up. And the next one is memory estimates. So we did kind of storage estimate, and right, tomorrow, if you want to talk about, if you want to have a cache, right? Because a lot of these requests might be for the same URLs. Does it make sense to build a cache? And then if it makes sense to build a cache, then what would be the memory that is required, right? So there's a very famous 80-20 rule, which says that 20% of the URLs will generate 80% traffic. So we would like to cache these 20% of these hot URLs and serve them fast. And if you go ahead with that assumption, right, considering you have 20K requests per second, we'll be getting 1.7 billion requests per day. And if you want to cache 20% of these requests, we will need around 170 GB of memory, right? And the thing you need to note here is that a lot of these requests might be duplicate. So the usage will be way lesser than 170, but it's still good to have a higher number. So these are some of the estimates. We thought about traffic, and then we thought about storage, we thought about memory and all that stuff. So it's good to talk through your estimates, right? Have these mental pictures in mind that, hey, I'm going to talk about these estimates. What does that mean, right? And the next thing that comes up is fine, you define the functional requirements, you have defined your estimates, and then now you're going to define your API. How is that going to look like? And again, defining an API is pretty straightforward. You can think of it as a function call, like in simple terms. And what it is like is, let's say you want to create URL, right? So we'll have an API def key, so some key to identify that user. And then there will be like, what is the original URL that the customer is trying to kind of shorten, and if he has any custom alias that he wants, or if there is a username, right, and if there is an expiration date for that. So these are things that the customer can set. By default they are none, and then you can have your algorithm accordingly, right? And what we would return is a shortened string, or basically if there's some issue, we'll just return some error code. So that's like a function definition, sort of like how these APIs are going to look. And if someone wants to delete that URL from this service, they're just going to call it delete URL, API or something like that. And it's going to have the def key to identify that, and then it's going to have the URL key. And basically that would remove that URL, right? So we have defined the system APIs now. So we're going to think about how do we actually, right, solve this problem.